There are several online forums where electricians and inspectors share photos of their work, including examples of code violations and interesting installations. These platforms can be valuable resources for learning, sharing experiences, and staying up to date with industry practices. Firstly, ElectricianTalk forums, found at the provided address, features a dedicated section for electrical photos. This forum is a broad platform for electricians to discuss various topics related to the trade, and the photos section allows members to visually showcase their projects, installations, and any issues they encounter. Secondly, InspectionNews forums, found at the provided address, caters to home inspectors and related professionals. While not exclusively focused on electrical work, inspectors often share photos of electrical defects and safety hazards they discover during inspections. This forum provides insights into common issues found in residential and commercial properties. Thirdly, NAACHI Inspectors Forum, found at the provided address, is specifically for members of the National Association of Certified Home Inspectors. It provides a platform for inspectors to discuss industry-related topics, including electrical inspections. Photo sharing can be a valuable tool for illustrating inspection findings and seeking advice from peers. Fourthly, Reddit has several subreddits relevant to electricians and home improvement. The r/electricians subreddit, found at the provided address, is a community where electricians share photos, ask questions, and discuss industry-related topics. The r/home improvement subreddit, found at the provided address, also contains discussions and photos related to electrical work, although it covers a broader range of home improvement topics. These forums offer a wealth of visual information and practical insights for electricians, inspectors, and anyone interested in the electrical field. When participating in these forums, it's important to adhere to the community guidelines and respect the privacy of others. Always obtain permission before sharing photos that involve private property or individuals. Remember that online forums are intended to be educational and informative, and respectful communication is essential. The Electrical Safety Foundation International, or ESFI, is a non-profit organization dedicated to promoting electrical safety in the home, workplace, and community. They offer a wealth of resources, including safety tips, educational materials, and training programs. Their website is a valuable source of information for preventing electrical hazards and promoting safe practices. NFPA 70E, Standard for Electrical Safety in the Workplace, provides guidance on protecting workers from electrical hazards. It covers topics such as arc flash, shock protection, and personal protective equipment. Compliance with NFPA 70E is essential for ensuring a safe working environment for electricians and other electrical workers. The National Electrical Contractors Association, or NAACHI, is a trade association representing electrical contractors. They offer resources, training, and advocacy for their members. NAACHI also develops and publishes standards and guidelines for electrical installations. The Independent Electrical Contractors, or IC, is a trade association representing independent electrical contractors. They provide training, apprenticeship programs, and advocacy for their members. IEC also promotes ethical business practices and quality workmanship. To further elaborate on the technical aspects of electrical work, it's crucial to understand the fundamentals of electrical circuits. A basic electrical circuit consists of a voltage source, a conductor, and a load. The voltage source provides the electrical potential difference that drives the current through the circuit. The conductor provides a path for the current to flow. The load consumes electrical energy and converts it into another form of energy, such as light, heat, or mechanical work. Ohm's law is a fundamental principle that governs the relationship between voltage, current, and resistance in an electrical circuit. It states that the voltage across a resistor is equal to the current flowing through it multiplied by the resistance. Mathematically, it's expressed as voltage equals current times resistance, or volts equals amps times ohms. Kirchhoff's laws are another set of fundamental principles that govern the behavior of electrical circuits. Kirchhoff's current law, or KCL, states that the sum of the currents entering a node or junction in a circuit is equal to the sum of the currents leaving the node. Kirchhoff's voltage law, or KVL, states that the sum of the voltages around any closed loop in the circuit is equal to 0. Electrical power is the rate at which electrical energy is consumed or transferred. It's calculated by multiplying voltage by current. The unit of power is the watt. Electrical energy is the total amount of electrical work done over a period of time. It's calculated by multiplying power by time. The unit of energy is the kilowatt-hour. Grounding is an essential safety measure in electrical systems. It provides a low resistance path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Grounding also helps to reduce electrical noise and improve the performance of electronic equipment. Bonding is the process of connecting all metal parts of an electrical system together to create a continuous electrical path. Bonding helps to ensure that all metal parts are at the same electrical potential, reducing the risk of electrical shock. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. They interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. Arc flash is a dangerous electrical phenomenon that occurs when a high-voltage electrical discharge jumps between two conductors. Arc flash can cause severe burns, blindness, and even death. Personal protective equipment, or PPE, is essential for protecting electrical workers from electrical hazards. PPE includes items such as insulated gloves, safety glasses, and arc-rated clothing. The electrical codes and standards, such as the National Electrical Code or NEACHI, provide guidelines for the safe installation and maintenance of electrical systems. Compliance with these codes and standards is essential for ensuring the safety of people and property. Electrical safety training is essential for all electrical workers. Training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. Proper electrical maintenance is essential for preventing electrical problems and ensuring the safe operation of electrical equipment. Maintenance should include regular inspections, testing, and cleaning of electrical components. Troubleshooting electrical problems requires a systematic approach. It's important to start by gathering information about the problem, such as the symptoms, the location, and the history of the equipment. Then use a process of elimination to identify the cause of the problem. When working with electrical equipment, it's important to always follow safe work practices. These practices include energizing equipment before working on it, using appropriate personal protective equipment, and following lockout/tagout procedures. Electrical work can be dangerous, but by following safe work practices and using appropriate safety equipment, the risks can be minimized. Remember that electrical safety is everyone's responsibility. Report any electrical hazards to your supervisor or safety department. If you are not qualified to perform electrical work, do not attempt to do so. Hire a qualified electrician to perform any electrical work that you are not comfortable with. Always be aware of your surroundings when working with electrical equipment. Look for potential hazards, such as wet floors, damaged equipment, and exposed wiring. Never work alone when performing electrical work. Have someone nearby who can assist you in case of an emergency. Keep your work area clean and organized. This will help to prevent accidents and make it easier to find the tools and equipment you need. Use the right tool for the job. Using the wrong tool can damage the equipment and increase the risk of injury. Inspect your tools before each use. Make sure they are in good working condition and that they are properly insulated. Never use damaged or defective tools. Follow the manufacturer's instructions when using electrical equipment. This will help to ensure that the equipment is used safely and effectively. Be aware of the limitations of the equipment you are using. Do not overload circuits or exceed the rated capacity of the equipment. Use extension cords safely. Do not overload extension cords or run them under rugs or furniture. Inspect extension cords regularly for damage. Replace damaged extension cords immediately. Use ground fault circuit interrupters or GFCIs in wet locations such as bathrooms, kitchens, and outdoor areas. GFCIs protect against electrical shock by interrupting the flow of current when a ground fault is detected. Be careful when working near overhead power lines. Maintain a safe distance from power lines and never touch them with any object. Call the power company if you need to work near power lines. Be aware of the location of underground utilities before digging. Call 811 before you dig to have underground utilities marked. Never assume that you know the location of underground utilities. Be prepared for emergencies. Know the location of the nearest fire extinguisher and first aid kit. Know how to shut off the power in case of an emergency. Call 911 in case of a serious electrical accident. Remember that electrical safety is a continuous process. Stay up to date on the latest electrical codes and standards. Attend electrical safety training regularly. Be proactive in identifying and correcting electrical hazards. By following these safety tips, you can help to prevent electrical accidents and ensure the safety of yourself and others. The NEACHI Table 310.15b16 and associated tables provide ampacity ratings for conductors based on insulation type, conductor size, and ambient temperature. These tables are crucial for selecting the correct size conductors for electrical circuits to prevent overheating and fire hazards. When performing voltage drop calculations, it is important to consider the length of the conductor, the current flowing through the conductor, and the conductor's resistance. Voltage drop can cause equipment to malfunction and can also reduce the efficiency of the electrical system. The proper selection and installation of electrical equipment are essential for ensuring safety and reliability. Equipment should be listed by a recognized testing laboratory, such as Underwriters Laboratories, and should be installed in accordance with the manufacturer's instructions and the NEACHI. Ensure all electrical boxes are properly sized according to NEACHI standards to prevent overcrowding of conductors and devices. Insufficient box fill can lead to overheating and potential safety hazards. When making wire connections, use appropriate connectors and ensure they are properly tightened. These connections can cause arcing and overheating, leading to fires. Clearly label all electrical panels and circuits to facilitate troubleshooting and maintenance. Accurate labeling can save time and prevent confusion during emergencies. Regularly inspect electrical systems for signs of damage such as cracked insulation, loose connections, and corroded components. Address any issues promptly to prevent further damage and potential safety hazards. Use surge protectors to protect sensitive electronic equipment from voltage spikes caused by lightning or power surges. Surge protectors can help to prevent damage to computers, televisions, and other electronic devices. When installing electrical wiring in hazardous locations, such as areas with flammable liquids or gases, use appropriate explosion-proof equipment and wiring methods. These specialized systems are designed to contain explosions and prevent them from spreading to the surrounding environment. When working with high-voltage equipment, such as 480 volts or higher, use extreme caution and follow all safety procedures. High-voltage equipment can be extremely dangerous and can cause serious injury or death. Always use a properly calibrated voltmeter to measure voltage levels before working on electrical equipment. This will help to ensure that the equipment is energized and safe to work on. When installing recessed lighting fixtures, ensure they are properly insulated and have adequate clearance from combustible materials. Recessed lighting fixtures can generate significant heat and can pose a fire hazard if not installed correctly. When working on electrical systems in older buildings, be aware of the potential presence of asbestos and lead paint. These materials can be hazardous to your health and should be handled with care. The NEACHI requires that all electrical work be performed by qualified individuals who are properly trained and licensed. Hiring a qualified electrician ensures that the work is done safely and in accordance with code. Consider the impact of harmonics on electrical systems. Harmonics are caused by nonlinear loads, such as electronic devices, and can cause overheating of transformers and other equipment. Use harmonic filters to mitigate the effects of harmonics. Understand the principles of power factor correction. Power factor is a measure of how efficiently electrical power is used. Improving the power factor can reduce energy costs and improve the performance of the electrical system. When working on electrical systems, always use a lockout/tagout procedure to prevent accidental energization of the equipment. Lockout/tagout procedures involve disconnecting the power source and placing a lock and tag on the disconnect to prevent it from being turned back on. Be aware of the requirements for arc flash hazard analysis. An arc flash hazard analysis is a study that determines the potential arc flash hazards in an electrical system. The results of the analysis are used to determine the appropriate personal protective equipment and safe work practices. Use ground resistance testing to verify the effectiveness of the grounding system. Ground resistance testing measures the resistance between the grounding electrode and earth. The resistance should be low enough to provide a safe path for fault current to flow back to the source. When installing underground wiring, use appropriate burial depths and conduit materials. The NAACHI specifies minimum burial depths for different types of wiring. Use conduit to protect the wiring from physical damage. When working on electrical systems in healthcare facilities, be aware of the additional requirements for patient safety. Healthcare facilities have stringent requirements for electrical safety to protect patients from electrical shock and other hazards. When installing solar photovoltaic systems, follow all applicable codes and standards. Solar photovoltaic systems can generate significant amounts of electricity and must be installed safely and correctly. Use appropriate wiring methods for the specific application. The NAACHI specifies different wiring methods for different types of installations, such as residential, commercial, and industrial. Use cable trays to support and route electrical cables in commercial and industrial buildings. Cable trays provide a safe and organized way to manage large quantities of cables. Understand the principles of motor control. Motor control circuits are used to start, stop, and control the speed of electric motors. Use appropriate motor control devices, such as motor starters, variable frequency drives, and programmable logic controllers. When working with electrical drawings, be able to interpret the symbols and diagrams. Electrical drawings use standard symbols and diagrams to represent electrical components and circuits. Be familiar with the different types of electrical drawings, such as one-line diagrams, schematic diagrams, and wiring diagrams. Use appropriate testing equipment to verify the proper operation of electrical systems. Testing equipment includes multimeters, clamp-on ammeters, insulation resistance testers, and power quality analyzers. Be familiar with the different types of electrical codes and standards. The NAACHI is the primary electrical code in the United States. Other codes and standards may also apply, depending on the location and type of installation. Stay up to date on the latest electrical technologies. Electrical technology is constantly evolving, so it's important to stay informed about the latest advancements. Attend electrical conferences and training courses to learn about new technologies and best practices. When working on electrical systems, always prioritize safety. Electrical work can be dangerous, but by following safe work practices and using appropriate safety equipment, the risks can be minimized. Remember that electrical safety is everyone's responsibility. Report any electrical hazards to your supervisor or safety department. If you are not qualified to perform electrical work, do not attempt to do so. Hire a qualified electrician to perform any electrical work that you are not comfortable with.